right, good morning, everyone. So we are going to talk in the next 25 minutes about capacity, more specifically about capacity constraints in your public cloud environments and kind of how Elastic was navigating those challenges. I'm not going to talk about the story alone.
Hey everyone, I'm Marc-Andre, but you can call me Marc because it's a complicated name if you're not French speaking. I'm an SRE at Elastic, and I'm working in the capacity team with Daniel, and they will tell a bit more about why we have a capacity team in a cloud environment.
I'm Daniel. I'm from Switzerland, working at Elastic since about 2 years, and I'm the team lead of the capacity team in SRE. So let me begin with physical machines. So in my past, I was kind of responsible for racking them up, cabling. I was super proud if it was nice and tidy eventually. So it was pretty satisfying if you can finally turn it on. However, till we get there, it was pretty tedious. We had to get budget. We had to get quotes for the best hardware. We had to order them, wait till they were delivered. We had to stock them, plan when we were going to install them, when the next rack was free, and then we could stage them and install it eventually. So now that's all gone because we have kind of the cloud and all the flexibility with it. So with just a couple of clicks in the cloud console, you can get whatever capacity you want to have, right? So the magic is done by just a couple of clicks. And yeah, this kind of removes all the need for planning ahead, right? Because that's their business, right? You can just click, right, Mark?
Exactly. I mean, if you've seen the Lego movies, like everything's awesome. Like we sing this song, the capacity team, all day. Like we don't need to plan for any major purchases. Like you just buy exactly what you need. When you don't need it, it just goes away and you don't pay anymore. We've also got all kinds of super amazing automation. Like we have GitOps, infrastructure as code. We even have chat ups now with ChatGPT and all those chatbots that are coming along. So you could ask ChatGPT, I want that new VM in the cloud, and poof, it all goes here anymore. So basically our job is amazing. Right, Daniel?
Yeah. And with that, we're at the end, right? Well, I guess not so much. Otherwise, you wouldn't be here. And for sure, I wouldn't be here as well. So let me talk a bit about Elastic and kind of what we do so you understand kind of our pain points. So Elastic is, like I said before, the company behind Elasticsearch. So Elasticsearch is kind of a search tool, open source since 2010. And there was a Norwegian company in 2011 which kind of took Elasticsearch and kind of offered it as a software as a service already on some cloud resource. This was done even before Docker was there. And this company was then acquired by Elastic, and kind of we offer now Elastic Cloud, where you can get your managed Elasticsearch clusters on AWS, Azure, and also GCP, right? So we try to kind of make it as easy as possible for you to operate Elasticsearch. So we are on 4 major CSPs in about 64 regions all over the world across all 4 CSPs. And we have around 50,000 deployments, how we call them, which are essentially boiling down to Elasticsearch clusters of various sizes. So there are single nodes, super small clusters, but also clusters spanning several hundred of nodes. And yeah, we have a shit ton of containers. And Elastic Cloud is founded and created so early, even before Docker was released, even before Kubernetes was a thing. So we actually built our own container orchestration tool. Well, it's not as nice as Kubernetes, to be honest. It's pretty painful to operate. But yeah, there are some good things about Elastic Cloud. So you can also have the control plane for operating Elasticsearch clusters as an on-prem product. It's called Elastic Cloud Enterprise. And it's actually exactly same control plane logic as we operate in Elastic Cloud. We are transparent about the cost of running the Elasticsearch cluster in the cloud because we are just billing you the underlying infrastructure your clusters need, plus a very small uptick of the cost. And yeah, we handle all the capacity provisioning. If your cluster scales out, it will automatically scale your cluster, the underlying infrastructure is provisioned. And yeah, apparently the customers love it because it takes out a lot of pain points of managing your Elasticsearch cluster on-prem. There are also some bad things. So the control plane is pretty much unaware of the underlying infrastructure. We had to build a lot of tooling ourselves around the control plane to provision the infrastructure, to do the auto-scaling of the infrastructure below. And yeah, Elasticsearch is kind of stateful, so kind of not the greatest application to run on a cloud-native environment. And it's very expensive because Elasticsearch is super memory intensive and CPU-wise as well. So there are actually even ugly things. So we can't even use the CSP provided auto-scaling mechanism because Elasticsearch has its own triggers when it needs to scale out. There is we are in 64 regions and not all types we would love to have are available in every region. And we somehow needed to abstract that. And once we are in a situation where a customer wants to scale out in a region where a type is not available, we get paged.
Well, why do I even work there if I can get paged out of office hours? That sucks. But we said before that capacity is infinite, but apparently no, it's not, unfortunately, because at the end of the day, cloud is always someone else's computer, right? So basically, we have I'm going to talk to you a bit about some of the errors that we've seen from different CSPs and some things that there's not that many things, but all those things come up with a bunch of errors that cause us a lot of headache. Some of it that we can see, if you look at those 2 error messages, by show of hands, who has seen some of it before? They're from 2 major CSPs that basically tell you that you cannot scale up your instance group. Nobody had that before.
There is some.
Oh, there's a few hands. Okay, sorry. With the lightning here, we don't really see the audience. Yes, and those things we see a lot because operating in 64 regions on 4 CSPs and we have a lot of instance types, at the end of the day, there's going to be 1 or more that is out of capacity. And also, one of the worst things that we have is that sometimes where you're going to have a message that says, hey, your instance is going to get terminated because it runs on degraded hardware, whatever. And you tell yourself, well, does it really matter? I'm running on an ESG or an instance group or VMSS, depending on the cloud provider. And it's just going to get replaced once it gets shut down. But what can happen is that, okay, if it's running on an instance type that's a bit older or that's very constrained, the replacement that tries to come up, well, there's no more capacity for your replacement. So what do you do then, and how you prevent this? Well, let's, Daniel, how did that happen? How we got there to have such a painful things?
Well, that's a really good question. How did that happen? Because you're pretty powerless at that moment because the CSP doesn't give you any more, right? So let me take you on a journey to kind of share some lessons we learned in, I would say, the last 10 years operating Elastic Cloud. So the first lesson is we made huge mistakes in the architecture, how we built our cloud service in the beginning, because we were kind of tight coupling how your Elasticsearch cluster is created from what kind of, we call them deployment templates, to what's the underlying instant type, which is kind of running your nodes eventually. But this makes it really hard if we want to sunset older instant types, because we would have to reach out to each and every customer, basically tell them, hey, we would need to change your kind of deployment template to the new version of it. And it also makes it really hard in kind of introducing new types. And if we are out of the specific type, well, there's no other option, right? So kind of eventually our customers will suffer because we are so inflexibly designed. Then another thing, Black Friday. So yeah, we have quite some retail customers which have some huge load spikes. And this means they scale out within a day 500 times the previous cluster size. That's quite demanding. And it's not just Black Friday. It's like, imagine some famous or some crazy cricket games in India or kind of some religious festival somewhere, they also have huge load spikes. We need to prepare for them, plan in advance, and besides the normal capacity planning we need to do in our organic growth. So we strongly believe that capacity planning is a core skill set of every SRE organization. So on service side, but also in infrastructure side. And it also means you need to know how you do projections of time series data. Not some data scientist who is responsible for doing that. It's each and every SRE's responsibility to do that. And yeah, if you have now those capacity projections, don't keep it for yourself. Your cloud service provider technical account management team, they are your best friends. So build those relationships, share the capacity projections you need with them, because they have more insights on their side. They have more information than they publicly disclose how deep their capacity pools are. And they are more than happy to relay your projections to their own capacity team internally. So with those lessons in mind, we didn't even fix a single problem yet. So Mark, how did we fix them?
Well, there's a few things for this. What we're going to discuss about, it really matters if you're operating at a somewhat large scale, like necessarily compared to us, like maybe a bit bigger or a bit smaller, but like if you're using some very specific types in certain regions. So for example, for us, we're in all CSPs. So in AWS, we have a Gravitron instance, which are ARM CPUs, and they have very good price to performance ratio, especially for what we do on certain tiers. So our customers want to use a lot of them, but in some regions they are very constrained. So it can become a problem with our flexibility. So with that in mind, I'm going to talk about first how we're designing our next generation products, related to those capacity issues, based on some lessons that we've learned, and also some things that we're doing that are independent. They're just doing cloud provider. And then we're going to talk about some things that you can bring home and potentially do in your environment to remove those pains. So this is like a pretty overall overview design of Elasticsearch Serverless, which is our next generation of Elastic Cloud. But that's not really important here. The really important part of this is we discussed before that it's stateful. Well, there was a lot of work done to remove the tight coupling between storage and compute. So now we're running on the bucket storage for the storage, and we use a cache, a local SSD cache, to make it super fast for the queries to run. But what this allows us to do in the capacity team is we can move around the instances much more easily. So when there is capacity issues, it's going to happen for a specific type in a specific availability zone. But if you look, for example, AWS, US East 1, I think there's 6 different availability zones. So if we say we offer our customers a minimum of 3 AZs, then that means that we can run on more than 3 AZs, making sure that we still offer the service in at least 3, but then we have other possibilities to get the instance type that we run without having to resort to a different priority. The other thing that we're doing is we're removing the tight coupling between the instance type and the resources that the customers are requesting. So what we've done is now we're also running on Kubernetes. We're getting rid of our homemade orchestration. Actually, not really getting rid of it, because the other Elastic Cloud product we still have to operate and maintain and provide capacity to our customers. So we'll still have those headaches for years to come. However, we want to stop the bleeding now. And so running in that, we're leveraging cluster autoscaler. So we've worked with the performance team to benchmark how our product runs on different instance types. And of course, the best price to performance ratio, we use that as our first priority. But then we also have second, third, and fourth priority. But if we run out of our first one, then we can still provide the service to our customer. And that's a much better customer experience. Like for Black Friday, right now, we're very good at planning with it because we have a lot more years under our belt. But at first, it was super painful, and there was a lot of issues, and customers were really not happy because at the end of the day, they use our service. And even if it's really the CSPs problem of providing them more capacity. At the end of the day, they cannot scale, and they have requests failed for their customers, and that's really not a good experience. Then I'm going to talk about what we do for guarding, but first I want to speak about capacity reservations. Any of you here, just by show of hands, who uses capacity reservations? Okay, so like maybe 25% of the room. So basically capacity reservations, at first they can look a bit not really good, because you create a new capacity reservation. That means that you tell your cloud service provider, hey, I want to reserve an instance of this type in this AZ, and then you start paying for it, but you're not using it, even if you're not using it. So we're going to talk later about why you should do it, and how you can leverage this to your advantage without incurring any more cost. And then some CSPs are introducing future capacity reservations. And these are amazing for planning for high demand events like Black Friday. So future capacity reservations, you're basically asking your cloud provider, hey, I would like to have X number of instances in this AZ, but for this specific time. And then this sends a request to them, and they either approve it or refuse it. So if they approve it, it's going to get translated to a capacity reservation for this amount of time. And that's very useful for planning for Black Friday or other high demand events. Like right now, we had Daniel was talking about the cricket match in India. We had a customer that had this happen during March, and we have a customer that scaled like tremendously in an Indian region. And you could say, well, it's just in India. Well, the CSPs are very regional, so the capacity cannot really move from Europe to India right now. So like when they want to scale, if more customers want to scale because there's more activity for this particular event, the capacity demands can get very regional. So just in summary, some of the things that we do is we reserve our instances, and we try to reserve them in advance for high demand events, so that we can actually provide a service to our customers. Also, we talked a bit about this, but planning and communicating with the CSP is super important. So if you know in advance that you're going to have a new large customer that is going to take a lot of compute resources, or you know that, okay, based on your previous years, you're going to scale about this amount, give this plan to their customer and tell them, hey, I'd like to go into those regions with those ties, and they will be able to tell us, well, maybe it's not such a good idea because we might be constrained in capacity. Or let's say you're planning on using D2 on AWS. Well, D3 is getting introduced in many regions, and you'll probably want to use this instead because it offers better price to performance ratio, and also it might have better capacity availability. And also, like discussing with your cloud provider means that you're going to get probably an insight on, hey, what is coming. You know, cloud providers' services offer changes very often, and it's very hard to keep track about what's coming in different regions. So getting the roadmap of those instances and new types is going to be very helpful for you to plan, and also probably reduce your costs at the same time. Next is automating for maintenance events. Like I said before, if you have an instance that gets terminated, you want to replace that instance. And by replacing that instance, you want to ensure there is capacity. So one of the things that we do is our goal is to cover all of our existing running fleet with capacity reservation. So what that means is that if I have 100 instances in US East 1A of D2, then I'm covering them with reservation. So if AWS is getting rid of one for maintenance, that means now I have 99, but I'm paying for 100. So since I'm paying for 100, before terminating that, AWS has to guarantee me that it's going to provide me with that other VM when I create it. So I'm going to get the replacement. And the other AWS customers that do not do this might not get it. So let's talk about some concrete take-home actions before I take a quick sip of water. So probing capacity reservations. So capacity reservations in pretty much all CSPs, you just pay for what you use. But that means that if I create a capacity reservation and I cancel it 5 seconds later, I've paid for that compute resource for 5 seconds. So by automating getting those capacity reservations and canceling them super quickly, I can get an idea of how much capacity can I actually get if I needed to scale. So if I need 100 more instances in 5 days, well, today I can do a capacity reservation for 100 extra. And if it successfully gets created, I cancel it. And I know that if I wanted to scale today, I would be able to get them. It does not guarantee you that in 5 days you will, but at least it gives you an idea. And then you have the information about the probe of the capacity pool depth, and you can do plan around what action I'm going to take based on that information. So if it gets refused, you might want to do a capacity reservation, a future capacity reservation, and ask or do a call with your cloud service provider. Hey, I'm trying to get this and it doesn't work. Do you have other suggestions? Is there anything that we can do so that we can get it? So you actually have the information and the power to do something about it. Next, start using future capacity reservations. Right now, it's in preview and public preview on the GCP, and we really hope that other cloud service providers start providing this service because it's really amazing, especially high demand events, scaling for big customers. For example, on Black Friday, we use this a lot for a bunch of instances in regions that we know customers will scale in the US. So it's really an invaluable tool for us. Also, plan availability zone support. We did a very bad mistake with the first version of Elastic Cloud by tying the zone that our customers are running with a specific zone in the cloud service provider. And frankly, our customers don't care if they run on US East 1A or US East 1B. They just care that they run on this amount of AZ so that they get the reliability that they expect. But they don't care about which specific one that they use. Next, do capacity projections. That's very important. Like Daniel said, doing capacity is a data problem. You need to look at previously what was your growth, what's your sales forecast, what's the company growth forecast, and then you can do something about, okay, how much am I going to need? It's not going to be perfect, but at least you're working with something. And then talk with your cloud service provider, Tam. He's really your friend, and he wants your business. So by talking to them about your plans of scaling is going to help them also plan their capacity if you're running at a large enough scale, and maybe suggest you how you can proceed to actually be able to scale and serve your customer, and do capacity reservation if you need to. Next, design for flexibility. Like that was a really big mistake that we did, and we're not repeating it with our next generation product. And we really hope that you don't make the same mistake that we did. So, question time.